Alright, okay, let's come with integration by parts video part 3. So okay, let's move on for more examples for these cases here. So I tell you that by using integration by part, you have to integrate this. So we have to apply the formula of u dv, so uv minus integrate v du. So we follow the system of LPET. Alright, so this is a suggestion. It's not a it's just a way of helping you in apply integration by parts with a peace of mind. Alright, for example, this is, you have don't have ln x here, but you have p here, which is x exponent. You so don't have exponent, but you have second square trigo function, right? So then you have choose a u and a dv. Now I hope you are more familiar, right, with integration by parts. So your u, you were choosing x, and follow dv, you were choosing as second square x. So, and we want second square x dx, sorry, it's everything here, second square x dx, u dv, right? So for this, you have to differentiate. As you differentiate, you're getting du dx to be 1, right? Du dx to be 1, so du is equals to dx, and integrate, then you have v equals to integrate second square, can be integrated by that formula, right? That integrate second square, you differentiate tangent, you're getting second square, right? Integrate second square, you're getting tangent x. Okay, done. You have done with all this. So it's time to perform integration by parts. So which is uv minus we integrate v du. So u is x and v is tangent x. U is x, v is tangent x, minus we integrate v. So v is tangent x and du will be dx. So after I apply the integral by part, I have u v minus integrate v du. So to integrate tangent x, if you still remember integrate tangent x that I discussed during the techniques of integration by substitution. So where I said that integration tangent and cotangent, you have to write it in the form of the ratio of sine to cos, right? And for cotangent, cos to sine. So, and for this part here, I think this is not going to perform integration by parts, means after you're performing integration by parts. So for this section here, you need the techniques of substitution. This is what a special case here. So substitution, where now I doing substitution method. Alright, integration by substitution, where I choosing u. The suitable function here will be always chosen from the denominator, where is cos x. Substitution, you just need a u, right? So then you're differentiating, then you have negative sine x. As you know, differentiating cos is negative sine x, and this crossover sine x dx, and the negative with the du. So I'm going to using the techniques of substitution halfway here. So tangent x, where the sine x dx, can you see that? The sine x dx can be replaced by negative du, right? Negative du, and 1 over with cos x. Cos x is u, right? So I have x tangent x, negative, positive, integrate 1 over u du, right? 1 over u du. So now becomes simple integrand. So you have x tangent, right? X tangent x plus with integrate 1 over u is ln modulus u plus c, right? So your u in this case here will be cos x. So this is the combination between the first we apply the integration by parts, followed by integration by substitution here. So there are many more problems that are more difficult, which involving more than one techniques. Alright, okay, let's see. I will give you some simple examples involving integration with two techniques. Alright, okay, this will be the last example for this video. I just talked about two special cases here so that you're exposed to different type of cases. So for these cases here, we have exponent and we have polynomial, right? But this case is special because that you have x power of 2 here. It's non-linear, right? It's non-linear. So usually if non-linear, you want to apply integration by parts. Sometime working, sometime not working, or sometime you need to apply substitution, integration by substitution. So as you see that the power here is higher than this, right? So if you're using substitution, if you're using u as x squared, you differentiate getting 2x, but which is not inside here, right? Which is not inside here. So, but we still can apply, okay? We still can apply. So where I can start with substitution, okay, let's see, we can try with substitution, u to the power x to x power of 2. So I try to differentiating this, then I getting du dx. Now I apply integration by substitution, so I getting 2x. So du will be 2x dx. So I can't see there is a 2 here, so I try to bring the 2 to the other side, and I have x dx. Okay, first I choosing u as x squared, so where I have du dx to be 2x and du to be 2x dx and x dx to be du over 2. So I can't see x dx here, but I can do some modification here. So where I can sharing the x cubed, I can rewrite as x squared ex squared, right? I can write as x squared ex squared, but where is the other x, right? X cubed can be write as x squared multiply x. X squared multiply x, you get x power of 3, right? So because I putting the x behind so that I can using the substitution method where dx dx, alright, x dx is du over 2. So I can replace this with du over 2. So then as this, I will become u, right? Now I can see that x squared can replace with u. So become u, du over 2. So then I rewrite, I become 1 over 2 u, du. So now we just focus on this part now. Which you have learned integration by part. So for this part, we need integration by part. So for these cases here is we apply substitution method followed by integration by parts. So, alright, since there are many u's here, so I'm going to use the formula of integration of capital letter u dv. Alright, using this u equals to u v minus v du, right? So that you're not confusing. So now you have u, right? So means that now your u will be your u, this u. So and your dv will be eu du. So as you're integrating this, alright, you integrate differentiating this d du. Usually this is x, but now it's d capital U over du, which is equals to 1. So means that du equals to du. And you integrate this, you are getting v equals to eu, right? So I perform the integration by parts here, which is half of u v minus v du. So half. So your u, your capital letter U is u, v will be eu, v will be eu minus with v is eu, d capital U is du. So I actually apply the integration by parts. So then I integrate. So alright, I'm going to write it here. So it will be equals to half u eu minus with integrate eu, right? Integrate eu, you're getting back eu plus c, right? So but you don't forget the u here is actually x to the power of 2, x to the power of 2. So x to the power of 2 ex to the power of 2 minus with ex to the power of 2 plus 1. Or I can rewrite this thing to be 1 over 2 ex squared. I can factor out ex to the power of 2, right? Ex to the power of 2, and remaining you have x squared minus 1 plus c. Alright, so I hope you understand. Right, I think that's all for this video.